Question 36 says if F1, F2 and F3 are fundamental frequencies of three segments into which a string is divided, then the original fundamental frequency F0 of this string is given by. Dear students, let the lengths of individual components be L1, L2 and L3, then the net length will be addition of these lengths. Now dear students, the frequency can be written as V by 2L. So therefore we can write C that length is inversely proportional to the frequencies. Therefore we can write down that 1 by F would be equal to 1 by F1 plus 1 by F2 plus 1 by F3, which makes option number 1 as the correct answer. Dear students, now let us proceed to the question number 37. Question 37 says a transverse wave produced in a stress string of linear density 4 into 10 raised to the power minus 3 kg per meter is represented by equation y is equal to 2 sine 1.25x plus 50t, where x is in meter and t is in second. The tension in the string in Newton is. Dear students, the speed of the wave can be written as under root of t by mu. Speed can also be written as omega by k. So omega by k can be written as t by 4 into 10 raised to the power minus 3. Dear students, as per the question, omega by k has a value of 50 divided by 1.25. On solving this expression, we get a value of t to be equal to 6.4 Newton, and hence option number 3 is the correct answer. Now let us proceed to the next question of the test. Question 38 says the frequency of tuning fork is 250 Hz. The velocity of sound in air is 340 meters per second. The distance travelled by the sound during the time in which the tuning fork completes 50 vibrations is. Dear students, it is given that the frequency is 250 Hz. Therefore, the time period of one vibration is 1 by 250. For 50 vibrations, the time taken is 50 by 250. That will be equal to 1 by 5 or 0.2 seconds. Now, dear students, we have to find out the distance that the sound travels in this time. The distance will be equal to 340 multiplied by 0.2, and this will be equal to 68 meters, and therefore option number 2 is the correct answer. Now let us proceed to the question number 39. As per question number 39, a source of sound producing wavelength 60 centimeters is moving away from a stationary observer with speed 1 by 4th of the speed of sound. Then the wavelength of sound heard by the observer is. Dear students, on using the formula that the apparent wavelength will be equal to 1 plus velocity s by v into lambda, where vs is the velocity of the source and v is the velocity of the sound, we can find out the apparent wavelength, which will be equal to 1 plus 1 by 4 into 60. This will be 5 by 4 into 60, which will be equal to 75 centimeters, and therefore option number 4 is the correct answer. Now let us proceed to the question number 40. Question 40 says Laplace's correction in the formula for the speed of sound in gases given by Newton was needed because sound wave in gases first propagates adiabatically, second propagates isothermally, third are longitudinal, fourth have long wavelength. Dear students, the Laplace's correction was given because in gases the sound waves propagate adiabatically and not isothermally. This is a fairly simple theoretical question for which option number 1 is the correct answer. Now let us proceed to the question number 41.